In this lecture, we're starting our very last unit, which is trigonometry. It's a long unit. This is going to consist probably of 8 lectures, so make sure that you follow along because you're not going to have a quiz in the middle of the 8 lectures. You're just going to have the 8 lectures and then a quiz at the very end. Okay, so let's get started. So trigonometry, in order to start it, we need to define it. Okay, so trigonometry consists of 3 primary functions. It's kind of one of the nicest parts of mathematics because it takes several different areas of mathematics and combines it. So you're going to see obviously our trigonometric functions, which we'll get to in a second, but then you're also going to see a lot of geometry in there and a lot of algebra in there. And a lot of logical thinking as well. So you're seeing the crossroads of a lot of different areas of mathematics here. So let's start with the trigonometric functions, and you've probably heard of these before. Okay, we have sine, we have cosine, and we have tangent. So in order to understand what these are, let's first talk about triangles, okay? Because trigonometry is based on the triangle, specifically a right triangle. So if we take any right triangle, okay, keep in mind that in a right triangle, you have a right angle, okay? This symbol, if you don't remember from geometry, this symbol means our right angle. Right angle is 90 degrees. This side is the hypotenuse, which is the longest side. The hypotenuse only exists in a right triangle. You don't have a hypotenuse in any other type of triangle. Okay, the hypotenuse is always opposite the right angle, and it's the longest side of a right triangle. Okay, let's talk about how we label triangles. It's the same regardless of what type of triangle you're working with. Just so that it's easy for you to refer to, this is universal. So the angles are labeled with uppercase letters. So we could call this A, this B, this C. There's nothing that says that it can't be, that you can't label this angle for example A, this one B, and this one C. Typically in a right triangle, we like to label the right angle C. You'll see why in a second, but it's not written in stone. Okay, so the angles are in uppercase. The sides are in lowercase, and the side that's opposite that angle, it's going to have the same letter but in lowercase. So this angle is A, the side opposite it, which means the side that is not used to create the angle. So every angle is created by 2 sides. If we took this side away, you would still have an angle A, okay? So this would be side A. Opposite angle B, we have side B. And again, if we erased this, so let's just do that. Hopefully it'll just erase that side. It didn't. If we take out that one side, you still have an angle B. So that's how we know what's opposite, okay? And that means that this side is side C. And one thing that many of you are going to be familiar with is something called the Pythagorean Theorem. please be careful when you spell this. I expect you to spell it correctly. I have seen some very weird spellings, so make sure that you spell it correctly so everybody knows what you're talking about. And the Pythagorean theorem says a squared plus b squared is equal to c squared. Now, you covered this a long time ago, and hopefully you proved it back then. So I'm not going to take the time to prove it here. If you do want to prove, then obviously contact me during my office hours, send me an email. You can also look this up. Okay, so a squared plus b squared is equal to c squared, and that tells us the relationship between the three sides. Okay, so we do have a relationship between the three sides of a right triangle. This is just geometry. What you'll see in a few minutes is that trigonometry is the relationship between sides and angles in a right triangle. So we're adding in this angles part, which here we don't have. Okay, it doesn't matter what these two angles are. A squared plus b squared equals c squared will always be true. Okay, let's go in and talk a little bit more about labeling. So first of all, a couple of other things that you need to know. We have x as a variable. Okay, we use x typically as a variable, but that usually is for things like distance. It could just be any unknown, and we can always use x. But for angles, a lot of times you'll see something else used as the variable, as the unknown. And what you'll see is it looks like a 0 with a line through the middle. Okay, this is pronounced theta. It's a Greek letter. And it's a variable used for angles. So if you're writing an algebraic equation like 3x plus 2, you typically aren't going to see a theta. It's not going to be 3 theta plus 2, because that would indicate that you're working with angles, and we're not. Whereas when we're using trigonometry, we are working with angles. So you're going to see theta a lot more instead of, let's say, x. Okay? And it's not that you'll never see x, you will, but you'll see theta frequently. So I want you to be familiar with that. And theta is just x. Okay? It's an unknown. Okay. So when we label, we can label a right triangle. And the way that we label it, so this is how we label the sides and the angles as unknowns. Okay? But each of these we can label in a different way. And the way that it's labeled is based on whatever angle we're using at the moment. Okay, so if we are choosing to use this angle here, okay, so we're looking at it from the perspective of that angle, then we could label the sides as the side opposite the angle, the side adjacent the angle, and the hypotenuse. Okay, so each of the three sides can be labeled differently. So the three sides can be labeled as opposite, adjacent, and hypotenuse. And the hypotenuse we already know is always opposite the right angle. Okay, that symbol is used to represent angle. The opposite is the one that is not used to create the angle or to form the angle. And the adjacent is needed to form the angle. There are always two sides that form the angle. One of them is the hypotenuse, one of them is the adjacent. So the adjacent would never be the hypotenuse. Okay. Opposite will typically use the letter O, adjacent will use A, and hypotenuse will use H. Okay, so let's label this triangle based on this angle here. So notice that if you change the location of the angle, if we use the angle at the top instead, then the location of the opposite and the adjacent is going to change. Okay, why do we say that? Well, first of all, the hypotenuse we always know is opposite the right angle. So if we were to draw some sort of line that goes from this corner of the triangle across, this would be the hypotenuse. Okay, and again, what we're saying is we're saying if we were to take out this line, we still have the right angle, and that's how we know that this is the hypotenuse. We don't need this line in order to create the angle. And that's how we figure out the opposite for theta as well. We say, which line can we erase so that we still have the angle there? So if we erase this line, then part of the angle disappears. Same thing is true if we erase this line. So the only line that we can erase so that the angle is still there, okay, so that theta is still there, is this one here. So this is the opposite. Once you know two of them, you know the third. But the adjacent here, we have two sides that make the angle, right? So in this particular triangle, the hypotenuse is one side that makes the angle, and the adjacent would be the other side that makes the angle. So that would be the adjacent. Okay, and we're just going to do this with a bunch of different triangles that are in different configurations, okay? And I want you to notice that if we used theta up here, then the side opposite would be this one, okay? So the opposite and the adjacent switch when we change the location of theta. So I'm going to write that in there just so that you have it. But you should be able to see it as we label these triangles. And theta is never going to be the right angle. So this would never be theta. Theta is here or it's up at the top, okay? Okay, so let's take a bunch of different triangles and just label them opposite, adjacent, and hypotenuse. After like the second one, you should start pausing the tape, doing it yourself, and seeing if you get it correct. So I'm going to just draw a bunch of triangles and then we're going to label them. And that way, when you pause the tape, you can pause it and then do a lot of them at once. All of them are going to be right triangles, so you're going to see a right angle in all of them. You can't do this with a different type of triangle. Okay, so let's take these 7 triangles and just label the opposite, the adjacent, and the hypotenuse, okay, based on the angle that you were given. So here we're given the angle over here. So you could start with whichever one you want. If we start with the hypotenuse, if we take this right angle here and we just draw a line across, this tells us this is the hypotenuse. Again, if we were to delete this side here, we would still have our right angle, okay? The opposite is going to be the one where if we take away the side, we're still going to have theta, okay? You can also, again, just draw a line across. This is your opposite. And then what's left over is your adjacent. Your adjacent is the one that's next to the angle. Adjacent means next to, okay? If two people are sitting adjacent to one another, they're sitting next to each other. So if this is the hypotenuse, that's one of the sides that's next to theta. So the other one must be the adjacent. Okay, let's take this one. We're just labeling the sides opposite, adjacent, and hypotenuse. Whenever you're ready, you should pause the tape, try and do these yourself. Okay, so again, let's do the opposite first this time. So the opposite is going to be across theta. So this one is the opposite. The adjacent is the other side. So it's the other one that creates the right angle. So this is the adjacent. And then again, the hypotenuse is left over. Once you can do 2 of them, you can always do the third because it's just whichever side is left over. Okay. In this one, if we do the adjacent first, the adjacent is the one that you'll see connected to both the right angle and the angle. Okay, because the adjacent is needed for both of them. So that's this side here. You see the little square is attached and the theta is next to that side. So this is adjacent. This one is the hypotenuse. This one is what's across the right angle. And then the one that's left over is the hypotenuse. Sorry, is the opposite. Okay. Here, the hypotenuse across from the right angle. The opposite is across the theta. And then the adjacent connects both. It's used for both angles. Okay, in this one, the hypotenuse is across your right angle. Your adjacent is the one that's connected to both theta and your right angle. And your opposite is what's left over. Here, the side opposite, we could draw a line through the theta to this bottom side here. That's opposite. The hypotenuse is our longest side. It's opposite the right angle. And then the adjacent is the one that uses both angles. Okay, that helps form both angles. Here, We have this side here. This side uses both theta and our right angle. So that side is the adjacent. This side is our hypotenuse. And the side that's left over next to our right angle is the opposite. Okay, so this is how you label your right triangles. Okay, so from here, we're ready to define our trigonometric functions. Okay, and these are definitions. They're not calculations. We are simply defining. And the definition of a trigonometric function is the ratio of the sides of a right triangle. So that's what trigonometric functions are. Okay, they are definitions. Okay, meaning you need to remember it. Okay, there's no way around it. You just have to remember. So we have three of them. We have sine of theta. Sine of theta is typically abbreviated just as sin. It is pronounced sine, not sin. Do not say sin. It is a sin to say sin. You say sine. Sin is an abbreviation only in writing. Okay, so the sine of theta. Now, you have to have a theta here. This is like log. You can't take the log of nothing. You have to take the log of something. So something has to follow. You have an argument that follows the log. Following the sine, you have an angle. Okay, the reason why you need the angle is that the sine is based on the definition of sine is based on the sides of a right triangle. And as you saw, in order to label the sides of a right triangle, we needed to know where the angle is. If we don't have an angle, how are we supposed to know which is the opposite, which is the adjacent, and which is the hypotenuse? Over here, how would you label which is opposite, adjacent, and hypotenuse? You wouldn't know. The hypotenuse you know, because it's always opposite the right angle, but the opposite and the adjacent, you would have no idea. So you would need to be taking the sine of an angle. And the sine of the angle is the opposite side over the hypotenuse. So typically you'll see it abbreviated as sine is O over H. Okay, by definition. Then you have cosine. So cosine is abbreviated COS. Again, you pronounce that cosine. It is just abbreviated in writing. This one is the adjacent over the hypotenuse. So this is just rewriting it. It is A over H. Okay, so typically adjacent is just A, hypotenuse is just H, opposite is just O. Then we have the last one is tangent. It's abbreviated tan. A lot of times you will hear people say tan of theta. You will not hear people say, and you should not hear people say cos of theta, okay? So this is the only one that sometimes people will speak the abbreviation to. And this one is opposite over adjacent. So tangent of theta is O over A. And again, I'm going to emphasize, if you leave out the theta, then you are incorrect. You are not writing a statement that makes any sense. If you have a function, you have to know it's a function of x. Here you have a trigonometric function. You have to know what your input is. Your input is theta. If you just write tan equals O over A, you are incorrect. Okay, now some people have a way to remember this. They use something called SOHCAHTOA. I'm a little hesitant to show this to you because if you don't spell this correctly, then you get it wrong. Okay, so SOHCAHTOA, each group of 3 letters gives us a different trig function. So this one gives us sine of theta. This one gives us cosine of theta. And this one gives us tangent of theta. Sine of theta, so the first letter gives us which the trig function it is. Then the 2 letters that follow give you the definition. So sine is O over H, cosine is A over H, and tangent is O over A. If you spell this incorrectly, then you're going to get it wrong. So you should only use this if you know how to spell it. But honestly, it's 3 definitions. You can remember the 3 definitions, okay? So sine is O over H, cosine is A over H, and tangent is O over A, okay? And we can make some conclusions about sine, cosine, and tangent. So first of all, H is the longest side of a triangle, which means O is always going to be less than H. Now we know something. When the numerator is less than the denominator, our number is going to be less than 1, okay? So if I have 2 over 3, that's a number that's less than 1. If I have 5 over 6, it's a number that's less than 1, okay? So sine of theta is always going to be between 0 and 1. Now, for right now, we say between 0 and 1 because we're dealing with right triangles and each side of a triangle has a positive length, okay? So let's just put that in here. For a right triangle, sine is going to be between 0 and 1, and so is cosine. Okay. Tangent could be infinite. Okay. Tangent could be a very, very large number, or it could be a very, very small number. Okay. That's because there's no relationship between O and A. O could be very, very small, and A could be very, very large. You could have a triangle. So this could go up to infinity because we could have a very large number or a very small number. So this would be an example of a triangle. Let's say that this is theta. This is your right angle. Here your O is very small and your A is very large. So your A is greater than your O here. And you could have the same thing the other way. Your O could be very, very large. So if this is theta again, here your A is very small and your O is very large. There's no relationship between O and A. Okay. This is theta. Okay, so O is much bigger than A here, but here A is much bigger than O. Okay, and what you'll see here is over here in a triangle like this, our sine is going to be bigger. Okay, it's going to be closer to 1 because O is bigger. Okay, so if you have 2 over 3, 5 over 6, 7 over 8, these are numbers that are close to 1. So your sine is going to be closer to 1 here, whereas your cosine is going to be closer to 0. Okay, and tangent is closer to infinity. Now, it doesn't mean that it's really, really large, right? If I have, let's say that our theta, let's say that our opposite side is 200 and our adjacent side is 2. You get a large number, but it's not infinite. It's just that it's a larger number, okay? It's increasing. It's a larger number. Whereas when a is greater than O, the opposite happens. The sine of theta is closer to, I should say, to 1 than 0. This is to 0 than 1. And this is really what we're saying here is we're saying that it's larger than 1. We don't know how much larger. It could be much larger. It depends on how much larger the opposite side is than the adjacent side. So here, sine of theta is going to be closer to 0 than 1. The cosine of theta now is going to be closer to 1 than 0. And the tangent of theta is closer to 0, meaning it's less than 1. Okay, it's just giving you some idea as to what's going to happen to sine, cosine, and tangent so that you can look at your answer and you could say, oh, hey, it's reasonable. Okay, so how can we use sine, cosine, and tangent? Well, if we're talking about right triangle trigonometry, because eventually we'll talk about other types of trigonometry, okay? If we're talking about right triangle trigonometry, then we're using it to find missing sides and angles. Now, this is true for triangles that are not right triangles, where I'm not going to spend a lot of time on that. But eventually we're going to be working with circles in the next lecture. So that's why I say in right triangle trigonometry. We call them trigonometric functions. Okay, so let's take an example. So we're going to do it mathematically first, and then we'll talk about some examples in the world around you. Okay, let's start with missing sides. So what do we mean by this? Suppose that we have a right triangle, and here's your right angle, and I tell you that this is 61 degrees. Okay, so that angle is 61 degrees. And I tell you that the hypotenuse is 10 centimeters. This is obviously not drawn to scale. And you want to find this side. and we'll call that side x. So notice we can use x. We would not use theta here because theta is not an angle, okay? This is, theta would not be an angle. This is a missing side, and theta is only used for angles, okay? So in order to do this, you're going to ask yourself two questions. You're going to say, what do we know? And you're going to say, what do we want to find out? And when we're talking about missing sides, we're saying, which side do we know? This is your first question. Your second question is, which side are we trying to find? So your first step here is to label your triangle, because you can't figure out which side we know and which side we're trying to find until we label the triangle, okay? And when we say label the triangle, we mean with your opposite, your adjacent, and your hypotenuse. Okay, so let's do that. So you're given an angle. Here's an angle. That's the angle that we're going to use in order to label our triangle. So the side opposite that angle is this empty side here. This is opposite. This side x is your adjacent. And this 10 centimeters is your hypotenuse. So now we can answer these questions. Which side do we know? Well, here we're given the length of 10 centimeters, so we know the hypotenuse. And then we're saying, okay, well, which side are we trying to find? Well, that's this side, that's the unknown side, and that's the adjacent. So the third question that follows, and I put this in red because this is like the big question in solving, okay, is which function uses the two sides we found in 1 and 2? And which function is that? Well, it's cosine. We have hypotenuse and adjacent. Cosine uses hypotenuse and adjacent. The cosine of theta is adjacent over hypotenuse. Well, now we just fill in the unknowns, okay? Now it's a plug and check. So the cosine of 61 degrees, that's what theta is equal to our adjacent, which is x, over our hypotenuse, which is 10. Okay? And now we just solve for x. Well, first thing that we're going to do is we're going to multiply both sides by 10. That will isolate x for us. So that tells us that x is equal to 10 times the cosine of 61 degrees. Okay, how do we figure out what 10 times the cosine of 61 is? On your calculator. You need a calculator. So I'm going to do it with the computer calculator, but you could just do it with your regular calculators. You need a scientific calculator. Sorry, that's old calculations. Okay. There are trigonometric functions on your scientific calculators. Here I have to actually go and choose it. So The one thing that you want to check is when you calculate something like the cosine of 61, because it's different for each calculator, do you type in cosine first and then 61, which you could see does not work here, okay? It's not going to find it. It just puts in 61, okay? Or do you type in the number first, which is true for this calculator, and then you put in cosine, okay, which is what you would do. This is the cosine of 61. And one thing that you can do if you're checking this right now, which you should have your calculator in front of you, is type in the sine of 30. Okay, so type in 30 and then do sine. If you're getting the correct answer, you should be getting 1/2. So if you're not getting 1/2, then that tells you you have to do it the other way. So you can see that if I try doing sine, sorry about that. If I try doing sine of 30, where I do the sine first and then I type in the 30, I get 0. I don't get 1/2, okay? So for this calculator that I'm using, I have to type in the angle first, and then I have to type in the trig function, okay? And you can see that, just so that you know, as the angle gets bigger, so let's just go back to this for a second, okay? As theta gets bigger, so here theta is really small, right? So here, the opposite is really small. We're going to get a sine that's very small. As theta gets bigger, our sine should be getting bigger also, because our O is getting large. So let's just write that down. So as theta gets bigger, so does the sine. Okay, because you could see here that our theta is growing. Okay, let me redraw this as a bigger triangle. So here's opposite, here's hypotenuse. Okay, so here our opposite is small and our theta is small. If our theta gets bigger, so now our theta is growing. Our opposite gets bigger, okay, which means that the sine gets bigger. The opposite over the hypotenuse is going to increase, because as the numerator increases, okay, the sine is going to increase. The whole fraction will increase. The opposite is true for cosine. As our theta gets bigger, you could see that our adjacent is decreasing, okay? Our adjacent is getting smaller. And when our adjacent gets smaller, what that tells us is that the cosine is getting smaller. Okay, and our opposite is getting bigger, our adjacent is getting smaller. That means that this fraction also gets larger. So as theta gets larger, so does the tangent of theta. Okay, so let's go back and let's calculate this. Let's calculate what x is. So let's go back to our calculator. Okay, we're going to do the cosine of 61. So I type in 61 and then cosine. Okay, and I'm going to multiply by 10. And I get 4.85. Remember, I would round to the nearest hundredth, always make a habit of that. The number after the 4 is an 8, so that tells us it goes up to 5. So our answer here is 4.85, which makes sense, okay? It's not, first of all, it should definitely be less than 10, okay? This is an angle that's bigger than 45 degrees, so this should be, you're talking about something that's, the adjacent gets smaller, remember, as the angle gets bigger, and the adjacent gets smaller as the angle gets smaller. This is less than 45 degrees, so it's going to be less than half, okay? If it's less than 45 degrees, we're talking about something that's, I don't want to be too specific here. This is a smaller side because it's smaller than 45 degrees. So it makes sense that this is going to be smaller, okay? But it's not going to be so small. If you look at this, this is not going to be a really tiny, tiny, tiny number, okay? And remember, all of it is about ratios. Okay, let's take another example. We're going to do a bunch of these. I'm going to label this A. This will be B. So this time you're given that this is 48 degrees. This is 21. And this is X. Okay, so you want to find X. So you're going to label first. And then you're going to answer each of your questions. So let's label this triangle. We're doing it based upon the angle that we're given, okay? Notice this is a missing side. If you didn't have an angle in order to find the missing side, you would have needed the other two sides so that you could use the Pythagorean theorem. So what this allows you to do is it allows you to identify another side of a triangle without knowing both of the other sides. Here we know one side and one angle, so we could find a second side, okay? So if we label this, X is the side that's opposite. The 21 is the hypotenuse. And this third side is the adjacent. So what do we know? Which side do we know? We know the hypotenuse again. Which side are we looking for? This time we're looking for the opposite. And which trig function uses opposite in the hypotenuse? Sine. So we answered our 3 questions, okay? Okay, so now it's a pluck and chug. The sine of 48 degrees is equal to the opposite, which is unknown, over the hypotenuse, which is 21. How do we solve? We multiply both sides by 21. So X is equal to 21 times the sine of 48. So we go to our calculator. We're going to type in 48 and then sine. Again, this might be different for some of you. So we get 0.74, okay, which makes sense as the angle As the angle gets larger, so does the sine of theta. So we get 0.74. And then we're going to multiply by 21. And we get 15.6. 15.61. Okay, so we want to round to the nearest hundredth. The next number is a 6, so that 0 goes up to a 1. Okay, let's take another one. Again, we're going to find x. Notice in all of these, we're finding missing sides. This is 22 degrees. This is 14, and we're looking for this. Okay. So what do? We label first. So we're going to label our triangle opposite, adjacent, hypotenuse. So the x side is our opposite. This is our adjacent, and this is our hypotenuse. Now we're going to answer our 3 questions. So our first question is, what do we know? Well, we know the opposite. Second question is, what are we trying to find? Sorry, I wrote that wrong. What do we know? We know the hypotenuse. What are we trying to find? We're trying to find the opposite. And which trig function are we talking about? Sine. Notice I always write sine of theta. Okay? So this is what we know. That's the first question. The second is what we're finding. And the third is the trig function. And now we just plug in. So the sine of 22 is equal to our opposite, we don't know what that is, over 14. And we've seen this before. What do? We multiply both sides by 14. Fourteen cancels. So we get that x is equal to 14 times the sine of 22. And if we plug this in, I always do the sine first. It doesn't matter. It just makes it so that I know I didn't mess up any sort of parentheses. And we get 5.24. So notice the next number is a 4, so we don't increase that number. We leave it as it is. So this is 5.24, and it should be less than 14, right? If you're getting a number that's greater than 14, you did something wrong, because 14 is your hypotenuse. Let's do another one. So let's say that this is 12 degrees. This time, the hypotenuse is unknown. And this is 6. Okay, so once again, you go through the same process. We label. So when we label this side down at the bottom, okay, side down at the bottom, that's the opposite. The 6 is the adjacent, and the x is the hypotenuse. So we go through our 3 questions. What do we know? Here we know our adjacent. What are we trying to find? Well, our x is our hypotenuse. Which trig function? Cosine. Cosine is adjacent over hypotenuse. Okay, let's plug in. Cosine of 12 degrees is, this time we know the adjacent. So the top is 6 and the bottom is x. Okay, so how do we solve this? Well, we need to get x by itself. Right now it's in a denominator. So it's a 2-step process, which eventually you can skip this step right here. Okay, so we're going to multiply both sides by x. That's going to get it out of the denominator. Whenever you do your algebra, when you have an x in the denominator, get it out of the denominator first. Okay, so now we have that x times the cosine of 12 is equal to 6. So now we want to get x by itself. So what do? You divide both sides by the cosine of 12. Okay, so you don't have to go through and multiply both sides by x and then divide by cosine of 12. What you're seeing here is that when x is in the denominator, you can actually just switch the x and the trig function. Okay, that's always going to be the case. If this had been tangent of 72 equals 10 over x, then you would make it 10 over the tangent of 72 equals x. In other words, you can go straight from this trig function set up to this one, which says that x is equal to 6 over the cosine of 12. So you're just switching the trig function with x. That's always going to be the case. Every time that you do this process, that's what's going to happen. So I'm okay with your going straight from this to this. So you're skipping this step. That's fine. Don't skip this one. Set up your trig function so that we know that it's set up correctly and you didn't make a careless mistake in there. Okay, so make sure that you leave this step so that we know that you know that cosine is adjacent over hypotenuse. Okay, and then you can go directly from here to here. How do we plug this into our calculator? You have a few options. Okay, my suggestion would be that you do 6 divided by, and then in parentheses, this was cosine of 12. So then you would type in 12 cosine, close your parentheses, and then you get 6.13. This is a 4, so you keep it as a 3. You don't up it. And again, what are you doing? You're checking for the reasonableness of your answer. So this is 6. The hypotenuse should be larger. If you're not getting a larger number, you did something wrong. Okay, so your answer should be larger. It's not much larger. That's because this angle is so small. Okay. Okay, let's do another one. Now you should be able to pause. We're going to do a couple more. You should be able to do those 2 on your own. Okay. Let's make this 35 degrees. Let's make this 11 and this x. And then I'll put in the other one as well so that you can do both at the same time. let's say that this is 18 degrees and this is 7 and this is x. Okay, so you should be pausing, doing these on your own, seeing what happens. So we label first. We're labeling based on the 35-degree angle, so 11 would be the opposite side, x would be the adjacent side, and then you have your hypotenuse. What do we know? We know the opposite. What are we trying to find out? The hypotenuse. And which trig function? Well, the trig function that deals with opposite and the hypotenuse is sine of theta. So now it's a plug and chug. Sine of 35 degrees is equal to 11 over x. Now here I'm going to go through the algebra again just so that you see it one more time. But again, you can go straight to the last step here. You don't have to go through the algebra every time. I'm okay with you skipping it. So we need to get x out of the denominator. So we're going to multiply by x. The x's cancel. So we get that 11 is equal to x times the sine of 35. Notice I switched the sides. That was unintentional, but it makes no difference. Divide both sides by the sine of 35 so that you get x by itself. So we get that x is equal to 11 over the sine of 35 degrees. So again, it's okay if you go from sine of 35 equals 11 over x to x equals 11 over sine of 35. I'm okay with that, okay? And then we go to our calculator and we do 11 divided by, in parentheses, close your parentheses, and you get 19.18. And let's just make sure that this is reasonable. Again, it's a 19.18 because this third number here is the 7, so it's greater than 5, which means this number goes up. Okay, so 19.18. Well, this side is an 11. Our hypotenuse should be greater than 11, and it is greater than 11. It's not much greater. This angle is 35 degrees. It's not that large, okay, or that small. So it's not going to be much greater. It won't be much different. 19.18 certainly seems reasonable, okay? That's all you're checking for is, does it make any sense? If you got 10, that wouldn't make any sense because this is 11, your hypotenuse should be larger, okay? Those are the types of things that you're looking for. Let's do the next one. So first thing that we do is we label. So the x is the adjacent. The 7 is the opposite. You don't even need to, sorry, the x is the hypotenuse. Sorry about that. Now you don't even need to put in the a for adjacent because that side is totally irrelevant, but it doesn't hurt, okay? You don't lose anything by writing a. What do we know? We know the opposite. What are we trying to find? We're trying to find the hypotenuse. And which trig function? Sine is opposite over hypotenuse. We'll do one more after this because I didn't mean to do sine both times. So what do we get here? The sine of 18 degrees is equal to 7 over x. So here we don't have to do all of the algebra. We can just say, okay, well then that means that x is equal to 7 over the sine of 18. So see, we skipped all of that algebra. That's okay. So you can go from here to here. And we put it into our calculator. We have 7 divided by, in parentheses, we do 18. And we find the sine. Close our parentheses. And we get 22.65. Let's go back, make sure it's reasonable. We're looking for the hypotenuse, so it should be larger. It is larger than the opposite. And it's much larger, but that makes sense because this angle is not all that big. It's only 18 degrees. Okay? Let's do one last one. Let's say that this is 9. This is x. And this is 41 degrees. Okay, once again, we're going to label. So the 9 is next to the 41. That's the adjacent. The x is across. That's the opposite. And what's left over is the hypotenuse. What do we know? We know the adjacent, right? The adjacent is equal to 9. When we say what do we know, we're saying what length are we given? When we say what are we finding out, we're saying, okay, well, what is x? X is our opposite side. And the trig function is tangent of theta is equal to opposite over adjacent. We plug in. Tangent of 41 degrees is x over 9. We multiply both sides by 9, so we get x is equal to 9 times the tangent of 41 degrees. So now we go to our calculator. We don't have to do division here. So when we don't have to do division, I kind of like doing the trig function first, but I'm going to do it the other way because some of you might like doing it the other way. So it would be 9 times, and then I would do the trig function in parentheses. Okay, so you do 41, and this time you're just going to choose tangent instead. And we get 7.82. Next number is a 3, so this stays where it is. Okay, and when we look at the reasonableness of our answer, we don't know if the opposite would be longer than the adjacent, right? We wouldn't necessarily know, except for the fact that this is 41 degrees. So it's less than 45. When it's less than 45, the opposite will be smaller than the adjacent, okay? And when it's greater than 45, the opposite will be greater than the adjacent. And you could kind of see why that would be, that once you pass the 45 degree mark where they're equal, okay, once you pass that 45 degree mark, the opposite starts to get longer than the adjacent. And before that 45 degree mark, that opposite is smaller than the adjacent. So this is a reasonable answer. It's relatively close. That's because our angle is relatively close to 45 degrees. So just think about it visually, that if we take this and we increase the angle, right, then the opposite side is longer. Whereas if we decrease the angle, the opposite side decreases, the length of that side decreases. So at 45 degrees, the two sides are equal. If we decrease the angle from 45 degrees, the opposite is now smaller than the adjacent. And if we increase the angle, then the opposite is now larger than the adjacent. So this is reasonable answer. Okay, so now we have missing angles, which is very similar. Okay, so for missing angles, let's just do a bunch of examples. So this time, you're given the sides, and the angle is what you're trying to find. So let's say that this is 11, and this is 8. So now you're asking, which sides do you know? Or which sides are you given? And which trig function uses the sides that you found in 1? So here it's really only 2 questions. So again, you're going to label your triangle. So the 8 is the adjacent, and the 11 is the opposite. The hypotenuse isn't really relevant here because it's not given to you and you're not trying to find it. Okay. So, which sides do we know? We know the opposite and we know the adjacent. Which trig function uses those sides? Tangent. Okay, so now, again, this is a plug and chug. Tangent of theta, theta is unknown, is the opposite over the adjacent. Okay, so now the question becomes, how do we find theta? We can't divide by tan because tan without a theta is just the color tan. It's not, we can't do anything with tan. Tan is a function, it needs an input. So you can't divide by tan. It would be as if I had 11 plus 2 and I tried to divide by a plus sign. You can't do that. So we can't divide by tangent. What we need to do is we need to get rid of the tangent on this side so that we only have the theta. What do? We do the inverse. It's the same way that we get rid of a square. To get rid of a square, we take the square root. To get rid of a square root, we take the square. Okay, so we're using an inverse function. So tangent has an inverse function. It's called tangent inverse. Okay, so this is just a side note. You're familiar with the notation, right? It's read as tangent inverse of theta instead of tangent of theta. Okay. This is the inverse function. So it will undo the tangent. Okay, so what does that mean? If we take the tangent inverse of both sides, the theta will disappear on the left. What you do to one side, you have to do to the other side. So the tan and the tan inverse undo each other. I'm going to put this in a different color, just so that you see the change that we're making. So you're taking the tangent inverse of both sides. And what does that mean? That means that what we're left with on the left is just theta. Okay, so a couple of things. First, you're already kind of familiar with this notation because when we did inverse functions, you saw that f inverse of x, right? You had f of x and then you had f inverse of x, which had a little -1 there. So you're already familiar with the notation. Second thing is tangent inverse is a function just like tangent. So tangent inverse needs an input. The input is 11/8. So here you're being given the ratio of the sides, and then given the ratio, you're going to find the angle, okay? Now what that means is that the 11/8 always has to come after the tangent inverse. In other words, there are some people who will write it as 11/8 tan inverse. You can't do that, okay? This is the input. It would be as if you wrote x, f for f of x. You can't, right? So the tangent inverse always has to come before. If you can't fit it, rewrite it. Don't put the tangent inverse on the other side, okay? So what we're saying is it is not okay to write it like this. Okay, tangent inverse of what? So don't ever put the tangent inverse on the other side. Okay, so how do we do this? So in our calculators, you have your trigonometric functions. So first of all, in your calculator, you'll actually see the function here. You'll see like tangent on the buttons. And if you press second, right, above the button, you'll see tangent inverse. So above the tangent button, you'll see the tangent inverse. So here, it's under trigonometry. If I press the second button, the place where the tangent was, there's now tangent inverse. Okay, now I already know on this calculator that I have to type in the 11/8 first, because that's how I would have to do it for tangent. So I'm going to do 11 divided by 8. Notice it's in parentheses. And now I'm going to go to the trigonometry and I'm going to do second tangent. Okay, so on your calculators, it was tangent. And I get 53.97. And that's a degree. Okay, this is over 45 degrees, so our opposite should be larger than our adjacent, and that's the case, okay? When theta is over 45 degrees, the opposite will be bigger than the adjacent. And I'm just going to add this in on the other page, that when theta is over 45 degrees, the opposite is greater than the adjacent. When theta equals 45 degrees, the opposite equals the adjacent. And when theta is less than 45 degrees, the opposite is less than the adjacent. It's just a little thing that might be helpful as you're doing these problems, just to say, again, we want to check the reasonableness of our answer. Okay, let's do another example. Let's say that this is 6, this is 14, and we'll make this the unknown angle. So once again, we're going to label our triangle. So the 6 is the opposite, the 14 is the hypotenuse, which means that this is the adjacent. We're going to answer our questions. So first one is, what are the sides that we know? Well, we know the opposite and we know the hypotenuse. Okay. And then which trig function? This is sine. The sine is equal to opposite over hypotenuse. Okay. So what do? We plug in sine of theta is equal to 6 over 14. And I'm going to do this again, okay? You don't have to, you can skip this middle step here. You don't have to do it every time, but I'm going to do it with this one so that once again you can see what's happening. So what are we going to do? We need to get rid of sine. So in order to get rid of sine, we need to take sine inverse of both sides. So on the left, we're taking the sine inverse of sine of theta. And on the right, we're taking sine inverse of 6 over 14. So here's what that means. That means that theta is equal to sine inverse of 6 over 14. Okay, so it is perfectly okay for you to go straight from here to here. Again, make sure sine inverse is in front of the 6 over 14. And then we go and we calculate it the way that we always have. 6 over 14 in parentheses. And then we're going to go, in this case, to trigonometry. In your case, it's just a second on your calculator. And we're going to plug in sine inverse. And we get 25.38. Okay, it certainly seems reasonable. It's not going to be perfect, but it seems reasonable. Okay? Okay, let's do 2 more. That'll be our first one, and then our second one. That'll be our second. So again, I encourage you, pause the tape and try it on your own. So first thing that we do is we label. The 20 is the hypotenuse, that's opposite the right angle. The 13 is the adjacent side. And then what's left over is the opposite. So the first thing that we want to know, which sides do we know? We know the adjacent, we know the hypotenuse. Which trig function are we talking about? We're talking about cosine. Okay, so just as a reminder from the last page, this first question tells us the sides we know. And the second question tells us which trig function. So we just plug in. Cosine of theta is equal to 13 over 20. So theta is the cosine inverse of 13 over 20. So notice, I did not write that we took the cosine of both sides, okay, but we did. You have cosine inverse of 13 over 20, so cosine inverse of something, okay? And we just put this into our calculator, 13 div 20, and then go to your trigonometry second cosine, and we get 49.46 degrees. Okay, if we do the next one, again, we're just going to label our triangle. So the 10 is the adjacent, the 15 is the opposite, then we have our hypotenuse. We ask ourselves the question, which sides do we know? Well, the opposite and the adjacent, we were given opposite is 15, adjacent is 10. Second thing is which function? Well, tangent of theta is opposite over adjacent. So now we just plug in. Tangent of theta is equal to 15 over 10. Okay. Notice our opposite is larger than our adjacent, so we should be getting an angle that's greater than 45 degrees. Okay. We take the tangent inverse of both sides. Make sure that you write this correctly. So we go to our calculator, 15 over 10. So I pressed enter so that it was like it was in parentheses. We're going to do tangent inverse, and we get 56.31, and that is greater than 45, so it's a reasonable answer. Okay, reasonable answer. Okay, so one more thing I want to introduce you to before we end, and that's something called reciprocal functions. So reciprocal trigonometric functions are exactly what they sound like. So the reciprocal of sine is called cosecant. And we're talking about reciprocal, so if you're doing the reciprocal of sine, sine is O over H, so this is H over O. And the abbreviation for cosecant is CSC. The reciprocal, no, I did that wrong. No, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. So if cosine is A over H, then secant is H over A. And the reciprocal of tangent is cotangent. So if tangent is O over A, then cotangent is A over O. Okay, so a couple of things about this. Excuse me. This seems a little counterintuitive, right? You would think that the reciprocal of cosine would be cosecant. But it's not. Every trig function has a co with it. So sine doesn't have a co, so its reciprocal function should have a co, okay? So that's why you have sine and cosecant. Cosine already has a co, so its reciprocal would not have one, okay? You have cosine, so you're not going to have secant. So you're just going to have secant. Tangent doesn't have a co, so its reciprocal must have a co. So you'll see cotangent, okay? The other thing is the abbreviation here is CSC because we can't use COS. It's already been used. So the big thing to remember is this, there's a co. Each one has a co. Okay, so how can we use this? So we're just going to do a couple of examples here because we're going to be doing this more as we go through trigonometry. So I'm only going to do 2 examples, okay? So finding all 6 trig functions. Given just one. Okay. So let's say that you are told that the sine of theta is 3/7. Okay? Find all 6 trig functions. So you can do this because essentially, now we don't know the angle. What we're doing is we're saying, okay, if the sine of the angle is 3/7, what is the cosine of the angle? What's the tangent of the angle? What's the secant of the angle, the cosecant of the angle, and the cotangent of the angle? Okay, so it's essentially a 3-step process. The first step is to identify the 2 sides that you already know. Okay, well, sine is opposite over hypotenuse. So we know that 3 is the opposite side and 7 is the hypotenuse. Okay, so you're always going to know 2 sides because you're given one of the ratios, and each ratio gives you 2 sides. Second thing that you're going to do is you're going to find the third side. And the way that we find the third side when we know 2 sides of a right triangle is we use the Pythagorean Theorem. Okay, the Pythagorean Theorem is a squared plus b squared is equal to c squared. But what does that really mean? C is our hypotenuse. So this is saying O squared plus A squared is equal to H squared. This is our Pythagorean theorem. So let's plug in. Our O is 3, so 3 squared plus A squared is equal to 7 squared. Okay, so we just plugged in for O, 3. We plugged in for H, 7. And A is unknown, so we're going to have to find it. So now this is algebra. 9 plus A squared is equal to 49. Subtract 9 from both sides. So we get that a squared is equal to 40. Then we take the square root of both sides. So a is equal to the square root of 40. And the square root of 40 can be rewritten as 2 times the square root of 10. Okay, the third thing is now we just write out each trig function. And there are 2 things that you have to remember to do. You want to make sure that you reduce all your fractions. And you want to remember to rationalize your denominators. So we're at a point in this semester where you know how to rationalize denominators. So now we can just go through each one. Sine of theta is opposite over hypotenuse, which is 3 over 7. That was given to us. Cosine of theta is adjacent over hypotenuse. Well, adjacent is 2 times the square root of 10. The hypotenuse is 7. Tangent of theta is opposite over adjacent. And opposite over adjacent here is 3 over 2 root 10. So this is a case where we have a square root in the denominator. We need to get rid of it. So all we have to do is multiply both the top and the bottom by the square root of 10. We don't even need a conjugate, because the square root of 10 times the square root of 10 is 10. So what we get here is our final answer is 3 root 10 on top and 20 on bottom, because remember, you have square root of 10 times square root of 10, which is 10, times 2, which is 20. And you can't reduce this. This is it. Okay. Now let's do the others. Sine of theta is 3 over 7. Cosecant of theta is the reciprocal. So it's just 7 over 3. Secant of theta is the reciprocal of cosine. So now this is 7 over 2 root 10. And you're going to do the same thing. You have to rationalize the denominators. So you have to do this extra step. So when you multiply both the top and the bottom, and you'll always just be multiplying by single square root because you're never adding or subtracting in here. So you don't have to worry about conjugates, okay? So this gives you 7 root 10 over 20. There's no reducing fractions there. And then you have your cotangent. So cotangent is A over L, which is 2 root 10 over 3 here. And that's it. Okay. Let's take another one. So let's say that we're told the cotangent of theta is equal to, let's make it 11 over 8. Okay, and again, we're going to find all 6 trig functions. So once again, you're going to identify what you know. So cotangent is adjacent over opposite. So your adjacent is 11 and your opposite is 8. Then we're going to find the hypotenuse. So we use the Pythagorean Theorem. O squared plus a squared is equal to h squared. So 8 squared plus 11 squared is equal to h squared. 8 squared is 64. 11 squared is 121. That's h squared. So this gives us 185. So h is the square root of 185. And let's just make sure that this can't be simplified, okay? So let's divide by some typical perfect squares, okay? So I know it's not that the largest perfect square that would go into it is 81. Because you remember, you divide by 2 and then you take the largest perfect square less than that. So 81 would be the largest perfect square. It doesn't go into it. So let's try one less than that. Let's try 185 divided by 64. That doesn't work. 185 divided by 49. That didn't work. So this is just an example of I don't know. I don't know the answer. So I have to do brute force. Divided by 36, no. 185 divided by 25, I don't have to try. I know it doesn't work. 185 divided by 16, no. 185 divided by 9, I know doesn't work. 185 divided by 4, that's not going to work because it's not even. So this is as simple as it gets. There is no perfect square that you could pull out. So h is just equal to 185. So now we identify each of the trig functions. So we already know that the cotangent of theta is 11 over 8. The tangent of theta is the reciprocal of that. It's O over A. So it's 8 over 11. Then we have the sine of theta. The sine of theta is O over H. So O is 8, and H is the square root of 185. But we have to rationalize our denominator. So we have to multiply both the top and the bottom by the square root of 185. So on top, we just get 8 times the square root of 185. We already know square root of 185 can't be simplified. And on the bottom, we get 185. Okay, and 8 doesn't go into 185. They don't have a common factor. Okay, cosecant is going to be the reciprocal. That's h over O. And that's just going to be square root of 185 over 8. So we have 4. Let's do cosine. So cosine of theta is 11 over the square root of 185. So again, we have to rationalize the denominator. So we're going to multiply by the square root of 185 over the square root of 185. And that gives us 11 times the square root of 185 over 185. Remember, the square root disappears. And finally, we have secant of theta, which is h over A, and that's just square root of 185 over 11. Okay, we'll do one last one, and then we're going to stop for today. So let's say that you're given that the cosine of theta is equal to, let's make it 5 over 8. Okay, and again, you're going to find all 6 trig functions. So our first step is to identify the two sides that were given. So cosine is adjacent over hypotenuse. So our A is 5, and our H is 8. Now we're going to use the Pythagorean Theorem. O squared plus A squared equals H squared. So O squared plus 5 squared is equal to 8 squared. O squared plus 25 is equal to 64. So this means that O squared is equal to, we're subtracting 25 from both sides. So 64 minus 25 is 39. So O is equal to the square root of 39. Okay, and square root of 39 can't be simplified, so we just leave it. Okay, I start with what I know. You could do sine, you could do it in whatever order you want. Okay, I just start with cosine because I already know it. Cosine of theta we already know is 5 over 8. Now because of that, we also know the secant of theta, because secant of theta is just h over a, or the reciprocal. So you can automatically say it's just 8 over 5. The others, sine of theta we could do next. So sine is O over h. So this is going to be the square root of 39 over our h, which is 8. Can't simplify. Cosecant of theta is h over O. So our h is 8. And our O is the square root of 39. You need to rationalize the denominator. So we have a square root. So what do? We multiply by the square root of 39 over the square root of 39. So that means that our cosecant is 8 square root of 39 over 39. And 8 and 39 don't have a common factor, so that would be it. And finally, we have tangent of theta, which is opposite over adjacent. So square root of 39 over 5. Okay. We don't have to do anything with that. The square root is in the numerator. We only have to rationalize the denominator. And cotangent of theta is the reciprocal. So that's 5 over the square root of 39. This one, we have a radical in the denominator. So we multiply square root of 39 over square root of 39. We're doing it that way because square root of 39 squared is just 39. So that makes the bottom rational. And that's it. Okay, so we're going to be doing stuff like this again, very, very similar. But I just wanted to introduce it to you. And that's all.